Welcome to Mr. West's Math Ship, Algebra 1 and Geometry. We're going to get our learn on today like we was cruising across calm seas. Everything's going to be clear and you're going to understand it. And we're going to have a good time. Yes, our cruise today, our math cruise, takes us to ancient Egypt. And it is in ancient Egypt that we're going to learn a little bit. Here are some pyramids. And we are going to jump on the camels and we're going to make our way out to the Great Pyramid of Giza. We'll have many moments that are very much Raiders of the Lost Ark moments. Here, I'll go on ahead of you and I'll stop at the tomb of Tutankhamun, which is King Tut. Here's part of our tour group, and there's old Mr. West right there going on ahead, waiting for you guys to come on and join us other students on the cruise boat that'll take us up the Nile River. Let's have a little fun. The tourist police are pointing out fun photos for us to take for our friends. Let's take a little break and rest. How about we check out some treasures from thousands of years ago that we can actually reach out and touch. A mosque perhaps. We can stop and check it out. The Great Colossus. Open air museums. Oh, what does that say? No climbing on the Great Pyramid, but I'll go ahead and pay a small bribe to the tourist police, and they'll probably let us scamper up about 8 or 10 rows. It's about that height you start getting scared when you look down anyway. No harm done. I assure you with my fez, I mean no insensitivity to Egypt or the Egyptian culture. I actually got this fez from Egypt from the tourist police. He traded me my hat for the fez. They don't really wear fez that much anymore in Egypt as they used to, but it's still a good thing for us tourists as we go check it out. So with fez on head and other things to come, let's dive into the math. Welcome back, math students. Here we go. We're going to take a look at the assignment from 2 nights ago. I'm going to do a couple of examples for you here. And this assignment, I had some people call in and say, or not call in, I had some people say, Mr. West, I don't know where the directions are. Well, they're right here. Okay, right here. The directions on this assignment are, you're supposed to look at each graph and you write the equation in vertex form, intercept form, and standard form. And I'm going to use this first one and do vertex form, intercept form, and standard form for you. And the thing that I need to point out, right off the bat is you have to know, or at least be able to look up or find vertex form, intercept form, and standard form. So let's remember the vertex form. I'll write it above here. Y equals some number A times x minus h squared plus k. And h and k are my vertex. The h is the x value of the vertex and the k is the y value of the vertex. So my vertex is going to be whatever number is in here for h and whatever number is out here for k. So let's look at an example over here. Let's hit the highlighter up and let's put a dot on our vertex. Our vertex is the place where the parabola is either at the minimum or if it opens down is at the maximum, and it's along the line of symmetry. It's the lowest point on this parabola opens up as the lowest point in the parabola. So we can write this equation in vertex form. I need to know my vertex, and my vertex is -3, 1, or 0, start at 0, 1, 2, 3 over That's negative 3, and then down 1, 2, 3, 4. So my vertex is at negative 3, negative 4. Okay, Egyptian travelers, so we have our vertex negative 3, negative 4. I'm just going to write that here, negative 3, negative 4. So in vertex form, I just copy this, and I'm actually going to put in the values right into the formula. Here's my negative 3, negative 4. I'm going to put them in for h and k and rewrite my equation. Well, let's quit talking about it and let's do it. All right. So I'm going to have to do a couple of steps on this. Let's start out with y equals, a is just 1. Okay, this thing isn't stretched or compressed. A is 1, so I'm not going to write a 1 there. Okay, y equals x minus negative 3 minus a negative 3 squared plus negative 4 plus a negative 4. Now I can rewrite this. I need to simplify this negative 3 and negative 4 in here and make the final version of my vertex form say this equals y equals x plus, because minus a negative means plus, 3 squared plus a negative 4 is just minus 4. So this would be my final answer for vertex form. And what can you tell from a vertex? Well, you can tell from vertex form, you can easily get the vertex. Okay, you can easily get the vertex. Let me clean that up a little bit. Okay, so I cleaned that up a little bit for you. You can go back and look back if you need to. Let's keep going. So, let's just say, so the thing that's easy to find from vertex form is your vertex. Okay. All right, now let's move on to the intercept form. Now the intercept form gives you your x-intercepts, and we write that in this form: y equals some number a times x minus p times x minus q. And this is also called the factored form. Many times the x-intercept form is also the factored form because we can see the factors right here of the quadratic. So in intercept form, let's find our intercepts. That's going to be the first thing we need to do. We'll make this a light blue. Here's an intercept at negative 1, 0 and negative 5, 0. Negative 1, 0 and negative 5, 0. How does that help me create the factored form? Well, pretty straightforward. I just put in the negative 5 and the negative 1 for P and Q. So I'm going to write this as y equals some A, which in this case it is not stretched or compressed, so A would be equal to 1. So instead of writing 1 times this, I'm just going to leave the 1 out. X minus negative 5 times x minus a negative 1. Okay. And we can rewrite that. Minus a negative 5 is going to be plus 5. Minus a negative 1 is going to be plus 1. So our final equation for intercept form is y equals x plus 5 times x plus 1. Okay, and this is our final answer here for factored form. And if we took these and multiplied them together using full, we would then get our standard form. And that is what we're going to do next. Let me clean this up for you a little bit and we'll move on to standard form. All right, passengers, the next form we have is the standard form. And that's the one we're all used to seeing. That is y equals some a x squared plus some b x, not squared, some b x plus c. This is the form we always see quadratics in very often, the old trinomial. And it's always squared, that's what makes it a quadratic. And it's always going to be a parabola. And remember, The parabola will always open up or open down. It will never open to the left or to the right. Remember, that would not be a function. That would be not pass the vertical line test. So all of our quadratic functions will open up or they will open down. So for this guy, the thing that we can tell real easily from the quadratic, from the standard form, is this C out here. This C is always going to be the y-intercept, the place where the parabola or the graph crosses the y-axis. So we know, before we start writing this standard form, we know that this plus C out here is going to have to be a plus 5. Let's see how we get there. For me, there's several ways you can do it, but I just like to look at my factored form and use FOIL, because I can easily always get my factored form from the parabola here. So let's check it out and let's do our factored form. I'm going to put my factors together, use FOIL to distribute them together, and show you how we get our standard form. X plus 5 times x plus 1. And remember, FOIL, first, outer, inner, last. First, outer, inner, last. My first is going to be x times x, as I distribute this in there. X times x is x squared. Out, that's my first. Then outer, my outer two values. X times 1 is plus 1x, and I'm going to leave my 1 there for a minute. And then my inner two, 5 times x is plus 5x. And then finally the last of each group, 5 times 1 is plus 5. Oh, there you go. See, there's that plus 5 already out there. So let's combine our like terms right here. We can combine this plus 1x and plus 5x to give us a final equation of y equals x squared plus 1 plus 5 is 6, plus 6x plus 5, and that is our final answer for our standard form of this parabola. We know that it's correct, but one place we can check is to make sure this plus 5, the plus C, is where the parabola crosses the y-axis, and it is. Let me clean that up for a second and we'll keep going. Alright, fellow tourists, take a look at that. Try to make some sense out of it. I'm just going to highlight the special features here, right, that pertain to the same color codes on the graph here. Okay. And then we'll go from there. Okay, so convert from intercept form to standard form. The name of the game here is FOIL, or distribution. First times first, outer times outer, inside times inside, last times last. Okay, over here you're going to do FOIL as well. You're going to do first times first, outers, inner, and last. Then after you get your trinomial, you have to distribute the 2 inside the trinomial. You'll be able to do it. Give it a shot. You can do this. This one is just use FOIL. Okay, what do you mean FOIL? What do I multiply? Well, so we're going to do FOIL, then subtraction for this guy. Let me show you what I'm talking about. This y, you're going to have to rewrite y. X plus 5 squared is the same thing as x plus 5 times x plus 5. So x plus 5 squared is x plus 5 plus x plus 5 minus 2. So you're going to use FOIL to distribute one into the other. X times x, that's your first. Outside times outside. Inside times inside. And then your last times your last. And that's going to give you a trinomial, something in the form of x squared plus bx plus c. I don't know what those numbers are. and then you're going to subtract 2 at the end. You're going to subtract the 2 from whatever this number c is down here, and you'll have a nice trinomial in the form of ax squared plus bx plus c, or minus something. And you can find your y-intercept once you have this final number. That is going to be your y-intercept. Same thing over here. You use FOIL for this. Then you distribute the 3 into your trinomial. Then you add 4 at the end. Okay, so on B, you're going to do FOIL. Then number 2, you're going to distribute the 3 into the trinomial. Right? It's going to have something like x squared plus something. You got to distribute the 3 in. Then after you get that, you're going to come in and you're going to add the 4 at the end. Add the 4. Okay? So you're going to have to factor these. You're going to have to factor, because intercept form is factored form. So here you're going to draw if you want an x factor, what multiplies to give me negative 15 and adds to give me 2? Well, start listing your factors of 15. 1 plus or minus 15 would be 14. You want the 3 and 5. There you go. It's got something to do with a 3 and a 5 over here, right? It's got something to do with a positive 3 and negative 5, or a negative 3 and positive 5. I don't know. But you can factor that, and your intercept form is just your factors. Look back. You'll see it. You can do that. Now, let's go forward. Convert from standard form to vertex form. Okay. Well, I'm just learning with you guys. Well, sort of, not exactly, but let's take a look at that. Let's look at this guy. Looking at that, I'm going from some ax squared plus bx plus c to, and this will be y equals, I'm going to y equals some a, and the a's are going to be the same, times x minus h squared plus k. I've got to go from this form to that form. One thing that's nice that you don't have to worry about is your a is not going to change. Right here your a is a 1. Over here your a is a negative 2. Okay? A is going to be a when you get it into the vertex form. Now we use a nice little formula. There's several ways to do it, but the easiest way I think is to use this little nice vertex formula. And this is going to give you the x value only of the vertex. The x value of the vertex. Mr. West, what are you talking about? I'm going to use this vertex formula. It's negative b over 2a, and that equals my x value of my vertex. So let's try it. Negative b over 2a, and my b is negative 10. Okay, so a equals 1 because there's no number in front of it. B equals negative 10. C equals 27. Well, all I'm interested in is A and B right here. Minus a negative 10 over 2 times 1. Minus a negative is a positive, so that's 10 over 2, which equals 5. So down here, my x value for my vertex is 5. I don't know my y value yet. Once I get my vertex, I've got this thing done, right? So if my x value of my vertex equals 5, all I have to do to find my y value of my vertex is plug 5 in for x. Let me move some of this stuff right here and we'll do that. If you need to see it again, you can rewind the video. I just plug 5 in. I'm going to plug 5 in for everywhere I have an x. So y equals 5 squared minus 10 times 5 plus 27. Now I'm getting my y value for my vertex here. Y equals 25. Negative 10 times 5 is negative 50, and plus 27. So get your calculator out if you need to. 25 minus 50 is negative 25, and negative 25 plus positive 27 gives you 2. 25, 26, 27. So my y value of my vertex is actually going to be 2. Now that I know my vertex, I know that my A equals 1, and I know that this is the vertex form. I'm just going to plug in my values and put it down here. Y equals 1, since A is 1, I'm not going to write a 1, x minus 5 squared plus 2. And that is my final answer. I hope you're able to follow along with that and use negative b over 2a. Over here, you're still going to do the same thing, but you're just going to notice that, hey, my a over here is what? A equals negative 2. So when I start my vertex form down here, it's going to be y equals negative 2 times da-da-da-da-da-da-da-da. Okay, because your a doesn't change. Remember to use your negative b over 2a to get your x value of your vertex. Plug that back into the original equation everywhere you have an x to get your y, and you're off to the races. Alright, this has been a long video. I apologize for taking you on such a long trip today, but hopefully that will help you with the assignment.